Good morning, everyone. We're going to get started with the first session of the talks today. Our first speaker today is Ashley Beecy. She's the Medical Director of Artificial Intelligence Operations at New York Presbyterian, where she's responsible for governance, evaluation, and implementation of clinical AI models. She's also an assistant professor of medicine and in the Division of Cardiology at Weill Cornell. She focuses her research on digital health, including safe and effective use of AI in healthcare. Prior to medicine, she worked as an electrical engineer at IBM, working on chip design architectures, and as VP of Operations Risk Management at Citi, she led planning, incubation, and development of many global initiatives, focusing on successful regulatory reviews. She's also consulted multiple digital health startups to develop strategy and improve operations in healthcare systems. Welcome, Ashley Beecy.
Thank you so much, and good morning. I really appreciate the opportunity to speak with you today. It's actually been a pleasure to be able to hear the different talks and also see the posters that represent such incredible work. I think that what we're seeing with the representation at the conference today and the work that you're demonstrating, as well as what's being published in literature, that there is a lot of excitement about how AI can improve healthcare and what the various use cases are that we can bring the technology to our patients. But what I want to talk about today is how there's a gap between some of what we're seeing that's being published and what we're able to bring to the bedside of our patients. I would even ask the audience here, how many people have implemented a model, an AI-based model, and it's patient-facing? So a fraction, right? I think this is an interesting number. It's probably, on under 10% of the people here that have been able to do this. And it's certainly possible, but what I want to talk about today is what are some of the challenges and opportunities that we can come together to actually increase what we're able to bring to our patients' bedside. And what I'm going to focus on is talking about how do we identify the problem? So how do we think about the right questions to ask using this technology that can be translatable to a solution to bring into our health system? How do we think about the deployment and the process of integration? And thinking about the solution performance, so moving beyond some of the technical evaluation to how we think about how this will impact our patients in totality. And then how do we increase transparency and trust to ensure adoption of these tools as we deliver them? So New York Presbyterian, it's a 10-hospital campus health system. We have a very diverse patient population. We have over 2 million patient visits a year, and we are affiliated with 2 medical schools, both Columbia and Cornell. And so I'm going to focus the talk on how at New York Presbyterian we are working to integrate AI into our health system. So first, computers will not replace doctors. They will complement them, but only if we ask the right questions. And so how do we do that? What is relevant? So I'm going to go through a couple items that I think are really important to start with. One is gain visibility into the priorities. So I can say at our institution, a couple of our priorities are to reduce friction for both providers and patients and also reduce the burden of chronic disease. It's also important to understand what some of the challenges are across your organization. That can be with the providers, that can be with the physicians, but also non-physicians. What are the challenges that our nurses are facing, that our radiology technicians are facing, that some of our administrative staff are facing? And I think if you take a deep dive into what are those challenges, you'll find that there's an opportunity for AI to really improve those workflows and make a difference. Characterize the problem. So we have a team that does intake of the problems. They're program managers and have product management expertise where they sit with the stakeholders and try to understand what are they trying to accomplish with this technology and what are the potential opportunities. to evaluate the existing workflow. This is incredibly important as we think about identifying the metrics and what you're trying to accomplish. You can say that if there is a model that can identify, or if the baseline of identifying a patient and treating them is 2 hours, and you build a model that can reduce that by 10% from about 2 hours to 1 hour and 45 minutes, does that actually make a change? Is that gonna change the patient's outcome? You really need to think of kind of what that solution is, even if there is a statistical difference there. Another example could be with that same 10% metrics. If we can go from, our retention, if we can reduce that turnover of staff from 10% down to 5%, well, that is a smaller percentage, but it could be a very impactful solution. Determine how the model will be integrated and really who is the end user. And I emphasize this because oftentimes the stakeholders that will benefit from the solution, they may not be the end users that will see the solution when it's integrated into the health system. So it's important to get both of those sets of stakeholders at the table in the conversation when identifying and thinking through the problem. You need to ensure that you have data and the appropriate labels and what the work effort is to both curate and annotate any work that you need to build the model, and also make sure that you have the data to collect to support evaluation of the metrics when the model's integrated. And then, I hate to say this at a machine learning conference, but oftentimes there may be a solution that's better than AI, something that's cheaper and easier, and it should be thought of as you're thinking about integrating the technology. And then lastly, to identify all the components, and I say this because it would be a shame when you do all this work to deploy a model, and then you find that if you're building a model, for example, to identify patients with a certain disease process, but there's not the resources or people to actually have a workflow to support that. So you have a prediction result, but there's nobody acting on it. Well, then you're not going to get the intended outcome. So these are all considerations when you're thinking about identifying the right problem. I'm going to start by giving an example related to heart failure, which is a chronic disease that impacts a significant amount of patients worldwide. It's anticipated to affect over 8 million patients in the United States by 2030, and really is associated with a high amount of costs in our US healthcare system. Heart failure is one of our enterprise initiatives. We have an enterprise heart failure team under Dr. Nir Uriel, who thinks about how to standardize the care of these patients across our enterprise and really close the existing care gaps. One of the initiatives is to partner with collaborators at Cornell Tech and Cornell University's College of Computer Information Systems or Science in order to expand our data science capabilities and think about how we can use artificial intelligence to improve the care of our cardiovascular patients. The reason why I use this as an example is because at the start of this collaboration, we had 20 clinical heart failure faculty members, and we had 10 technical faculty members, and then students associated with them, and we all got together. And you can imagine what that Zoom call looked like. The clinicians were saying, well, what is AI? How can I use it? And the technical faculty don't know anything about cardiovascular pathology or physiology. And to bring those groups together and really get the collaboration kicked off right took a lot of effort. And I think that goes back to identifying the right problems. One of the ways that we did it to get started was to define what our areas of focus would be, which is diagnosis, prognosis, and risk stratification, and this was an iterative process, and then figure out what were the topics of interest where we could make or gain short-term returns with this type of technology. And so we've spent about 3 months really iterating on this process and trying to close the gap between understanding the clinical nature and care gaps and also what the technology can do in healthcare. And we came up with a whole set of questions that we're actively pursuing, which is going to be the foundation of a broader collaboration. I need to mention that to do this in parallel, we've been thinking a lot about our cardiovascular data structure. When identifying the right problem, you really need to think about the data sources and the availability of that and what the work effort will be. And we've done work across our life cycle to think about how can we at scale, aggregate our electrocardiograms by extracting the XML files. How can we do system integrations with our cardiopulmonary exercise testing, our electrophysiology reporting systems into our data lake so that that data is available? Can we make sure that all our data is archived as it relates to our telemetry systems and that's saved in our data warehouse, so that all of this information can be used for data science purposes? And this work has extended across the life cycle all the way to the research repositories that are being built. So AI is poised to transform medicine if we can empower our providers by effectively delivering this assistive technology into the healthcare system. So how do we effectively deliver this technology? I like this graph because we know, everyone here knows, that model training is a lot of work. That takes a lot of expertise and something that I'm sure everyone here is very familiar with and excels at. I mentioned the data curation, all the work we're doing as it relates to data to prepare for building these models and evaluating them. But it shouldn't be underestimated how much work goes into the deployment of the models and how you need additional resources to accomplish this task. When we think about the deployment and the integration of the models into our healthcare system, I think of it broadly in terms of our software development lifecycle. And this is a process that we've outlined for our developers, and that's to start with the model that's been built typically in the retrospective environment. This model has been built on usually historic data, and we can understand what is the data that it's trained on, what is the population, how will that population mirror the population that the model will be applied to, were there any surrogates used for the training data or labels, and how will that impact things like bias? What was the performance on the historic data and its generalizability, and what is the intended integration? And then thinking about working with our IT providers to do a silent evaluation, connecting the model to production feeds and seeing if the model performs equally as well, understanding whether even the data feeds from the retrospective evaluation mirror the production feeds and how that can impact the performance. Implementation evaluation, so starting with a smaller scale pilot study, are you going to do an A/B evaluation, a pre-post evaluation? How are you thinking about doing that, and also whether it's effective and what is our threshold for that solution performance to think about scaling it across the entire enterprise? And then lastly, how would we monitor that over time and make sure that the intended clinical impact is achieved? This is work done by my colleague, Dr. Pierre Elias. I think you heard him speak yesterday. And what him and his team have done is they have taken electrocardiograms, which are a cheaper, more readily available test, and come up with a tool to screen for patients with more advanced valvular heart disease. This is an incredibly valuable tool, and they've really set the stage for how we should think about deployment into our healthcare system, taking the electrocardiogram, bringing it to our cloud environment, running their model, and then sending out a report of patients that should be screened with subsequent testing with an echocardiogram. Another example of this deployment is work done at our informatics, the DBMI at Columbia, and what they've built is a summarization of longitudinal patient records. This tool has an interactive visualization, was deployed in 2016 at NYP, and what they saw that there was over 10,000 users, and that the impact was that 50% of nurse abstractors had a significant reduction in chart review time. And with both of these types of models, we're using it as baseline to think about what is the architecture needed and the deployment pipeline for models that are based on, structured variables versus notes and LLM-based versus imaging or multimodal data. We're done, right? We've integrated it. We've brought it into the EHR. That should be it. That's a lot of work in itself. But the life cycle goes beyond that. The life cycle extends to how are we going to monitor these solutions over time and collect data and analytics related to things like data drift, the performance of the model over time, the technical monitoring of the solution or the application and its run times, the outcome metrics that we defined at the start of our study, and then regulatory and compliance. Are we moving from a research space and product to a commercial product or a product that's going to be disseminated and requires further review? This takes a multidisciplinary cross-functional team. It takes program managers to do the intake and product managers to understand the workflow and the integration. It takes cloud engineers and data engineers and people to build the APIs and DevOps teams and interface teams with the electronic health record, and then resources to evaluate those monitoring and analytics over time again. So we need to evaluate not just the model performance, but also the solution performance. So I love AUCs, just like I'm sure everyone here does, but I think as I mentioned, there's a lot of influences that happen by the time the model is built and integrated, and that can be everything from, again, the production feeds and the data that's used. It can be the integration itself. It can be the impact of the user interface. It can be the impact on whether the solution is adopted, and even biases that are introduced with the acceptance and use of the model. And so we need to incorporate all of that beyond just the statistical metrics that we used in the retrospective evaluation. And so in order to do that, it's important to have a governance structure or an oversight group that can think about the transparency, safety, and equity or fairness of the deployment, and really take a deeper dive into evaluating it and approving it for integration. And this can be related, again, to the data quality or the data used, the application, the interface, the intersection of models. If people are trying to do models that may have competing predictions, how do we think about that in our healthcare system? How do we relate that to any vendor solutions that are being applied and think about it as a whole in a more strategic way? How do we think about things like bias and explainability, the regulatory and legal frameworks? And so to do this, we put together a team which is evolving and is multidisciplinary, that has expertise related to data science, informatics, the interface team, regulatory and legal, our Dalio Center for Health Justice, implementation scientists, and also the program operations team. As you can imagine, in a large health system, there's a lot of different oversight committees and governance structures, and making sure that they intersect appropriately and don't overlap to create overburdensome nature for investigators is important. One example that I will give of actually our first model to go through this group is related to the risk of postpartum depression. So postpartum depression is a life-threatening mental health condition. It can affect 1 in 7 mothers. It often goes unrecognized, although National Society guidelines recommend screening patients for postpartum depression. One of our investigators and data scientists at Cornell, Dr. Ye Zhang, built a model to identify the risk of postpartum depression, and she brought the model to the group and did a wonderful evaluation that she had published on. And when she was asked about the inputs to the model, she mentioned that race was included. And it struck up a lot of conversation on how should we think about that. Our Center for Health Justice had just gone through all of our CDS tools related to things like PFTs and GFR, and thought about removing race and getting rid of those bias by taking out that element as an input. And now we're thinking about more complex models and including that. How should we think about that as a health system? And what it pushed us to do was come together with our Center for Health Justice and come up with a draft of a bias and fairness assessment process. Now, this is not a technical document outlining, how do you do fairness evaluation in machine learning, but rather a general guidance document for developers to say, what are the types of questions that I should be asking? They can be related to whether for data inputs or outputs what you're training against, or any surrogates used that may impact how we should think about the model, whether it's healthcare cost as a marker for severity of disease is one of the commonly cited examples there. But also can bias be introduced in other ways? I mentioned the data that which the model was trained on and whether it represents the population, and we think it can be generalizable, but also all the way through the life cycle to adoption, and thinking about evaluating the performance of the model across different protected classes as appropriate. And what we came up with, I will just say, is that this needs to be taken on a case-by-case basis, was really kind of the summary of it, but we should provide guidance. A system where AI augments human capabilities can improve patient care while optimizing the patient and provider experience. I think it's important to note that communication with the end users for this technology is incredibly important. We're not trying to replace humans in their work in the healthcare system, right? Humans have a complex way of thinking and integrating data, but these technologies are really meant to support them, and whether that's to remove the rote tasks that we have to do on a regular basis to make their job easier, or synthesize the massive amount of data into something that's digestible and can be incorporated in their decision process. But I want to emphasize that the communication will increase transparency, and I think ultimately lead to better products and adoption. This can include having a user-centered design approach, having an iterative, a work group take a look at the user experience or design and interface, helping explain to people what artificial intelligence is and what you're trying to accomplish, provide the appropriate education and tools to do this. And also, I think an important part of this is if there are studies, communicating the results of these studies to the end users who the data was incorporated or the solution was incorporated into their workflow. I think that'll enhance the way we get feedback back, feedback to iterate on the solution, and really will lead to better outcomes over time. An example of this is our falls risk prediction. So about 1 million patients fall inpatient across hospital systems each year. This can lead to a lot of severe injury and has been a focus for our nursing informatics group. And what they are building is a falls risk prediction tool, and they've really focused on increasing that transparency with the nurses across the enterprise. They're doing this by ensuring that the more heavily weighted predictors are available and transparent to the end users so they can see what's driving the prediction that they're acting on, and also created a whole education module to roll this out that nurses will look at as we go to implement the solution. And there's a plan to communicate what the results of this pilot were to the nurses after, so that they can understand how incorporating this tool actually made an impact across the hospital. I'm going to bring this back to the heart failure work that we're doing. I mentioned before that you need to think, when you're integrating a model or thinking about the right questions to ask, what are all the components beyond just the technology? And this is an example of one. So we're building a model to identify patients with heart failure, and we have worked to hire heart failure navigators to now take a look and build a workflow to support the prediction results and identify the patients on the list, see them, aggregate information that's related to their care in a registry, and we will be able to use that information to, over time, continually improve on the model and drive better results. And I think this is really truly an example of a learning health system approach to garnering feedback in an automated fashion on model results and iterating on it. If you build it, they will come. I'm not sure that is going to apply to this. So one of the things we are doing is planning on pulling together our investigators across the enterprise for an enterprise applied clinical AI work group where we can communicate that this service and these resources are available and get feedback on them, to share that bias document, to understand that from the people that are doing this work, are there other considerations that need to be made, and how we can improve it, and also to hear what are the resources that are needed to accelerate this work. Is there certain data priorities? Are there certain compute needs that we can do as an institution to better bring this technology to the bedside? And I'll kind of end with this before the summary slide, that we just have an incredible opportunity being part of an academic medical center to be able to bring the brilliant researchers together to develop these tools, and as a health system, bring the technology to our patients and iterate on it, and really start with a needs-driven approach. We can build all the technology solutions, but we don't want to be a hammer looking for nails. So starting with that right problem and building the technology around it is something that I feel strongly about and think that we do well. So in summary, it's important to spend time up front understanding the problem, the proposed integration, verify the presumed value propositions via testing in a real-world environment, understand the performance of the model beyond just the retrospective model statistics, and how the solution performance is impacting patient care, and then build a consensus and trust with the stakeholders through improved transparency and communication. There's a ton of people that are involved in this. It's just such a privilege to represent their work. Everybody across Columbia, Cornell, NYP, and then national organizations such as the Health AI Partnership, which has been integral into sharing ideas in a national forum. So I appreciate that. Thank you.